Welcome back to the workshop, lads. Another box of goodies just landed. All broken, needing fixed. Let's tear into this stuff. Let's see what can be, or if any, can be fixed. 2 drills, 9-inch grinder, and a 4.5-inch grinder. We'll start with the one in pieces. Push button switch. Power switch, he says. Right. Power switch is jamming. Doesn't seem to be broken or worn at all. Don't know if anything's actually wrong with this one or not. I don't like about Hikoki's. This glue on the screws. It's very annoying, especially when it interferes with the slider. These are cheap and cheerful Hikoki grinders, to be honest. Cheap to buy, good enough to run, but once they break or wear out, generally they're that cheap to buy you just replace them again. Even to change a lead and a set of brushes in one of these probably work out too expensive. Now just make sure that switch is definitely engaged before putting on your cover. Now, it's a funny one. It's not the switch. So, we have a switch. So we'll replace this. These are only starting and then stopping again, because these switches have a speed control built into them, or a soft start. Not really a speed control, just a soft start, so it doesn't start with a bang. And a soft start can eventually give trouble. Just pull out your connectors. And just pull your switch out. This one's been modified. Must be a known problem. The heat sink's gone on this one. That must be a known problem. Must have done away with the soft start. No, that's not right. Not good. Mightn't have been the switch at all. Oh, it's not the hot thing. Oh yeah. Yeah. Here's where the heat's coming from. Oh, it got hot quick, hey? The field's gone. That started, but speed control's gone. So that's why she cut out. This is shorted out on side. This field's totally gone. She must be making contact with the steel body. There's not even any paper lamination or nothing on the field. That is a cheap design. So she's been overworked, heated up, burnt the field, burnt the contacts. These two segments are now making contact, basically acting like a radiator, generating their own heat. All that current has probably cooked the switch. I assume this was the problem. New switch shows up the actual problem. So that now, if I put a meter on this, yeah. So basically, that field is cooked. It's shorted out on side and it's causing the thing to draw too much power. Blew the switch. This would not be worth a field and a switch. Switch is €20. Field's going to be another 15 or 20 euro. You could probably pick this thing up for 40. So she ain't going to be worth doing. Take that out and just leave it be. Forget about this one. On to the next. Hammer stopped working. Right. No hammer out of that. Making the motions but not making the sound. So she's done some work. That's probably why she's got no hammer. She's got no grease in the gearbox. It's all inside the motor. These things have no actual seal at the back, so there's no way to stop the oil getting out. Use grease inside, you see. Once you're running a hammer, not a problem. Grease just works its way around. Once they get overworked, which this thing clearly is, well, it's 2021 or 22. Once you start using them for a couple of hours at a time, this thing starts getting hot. Motor gets warm, gearbox gets warm. That grease starts to liquefy, becomes more runny. It's more runny, less viscous, starts to come out through the back. So that's why you see it all pulled up here. And it starts going down here, getting onto the fan, and gets thrown around inside the motor. So there's no seal in this because it's not got oil in it. Doesn't really need a seal because there's no oil. Grease should be thick enough not to come out. But when the thing gets heavily used, that grease basically turns the oil, starts flowing out everywhere. There's the problem. Striker down on here. It actually hits your chisel. It's jam solid. Right, now we tidy up so we can see what we're doing. Really into this striker pin inside to get it out. C-clip here, it wraps the whole way around inside to prise that up, generally on both sides. One side out. See if we can get the other. Doesn't want to budge. There we go. Get yourself something with a good strong hook. That's just a screwdriver with a notch cut out of it. Hook onto that C-clip. Get it in the middle. Pull it out. And there's your problem. One broken steel washer. Striker's okay. So is these. Apart from a few bits of metal. That'll survive, and they'll survive. Just this one is broken. So that's actually all I can do with this one for now. I definitely have not got this little O-ring, or holder sleeve is what it's called. I'll have to order that on. Don't even know the price. Doesn't even come up listed as a part number for a price on it. Probably never brought it on before. We have a month or two before I get that, so this will be fixed at some other stage. Next up, brushes, lost cover. She's a bit black, but is she any good? Barely any wear on that brush at all. It's basically new. So the question is, what was that one like? Actually, she might be alright. She's not too bad. Bit blackened, so I'd say you must have melted or burnt the brush holder. Yeah, it doesn't look too bad. Unless it did get hot and just cracked the brush. Looks alright otherwise. Clean it out, get a set of brushes. Alright, that's them cleaned out, or blown off, just basically. Get that looking a wee bit better, get off the dust. These things are being fairly abused. Company sent these on, sent on stuff before. They're basically just doing demolition, restoration job. And they're fairly hard on tools. Now, here's the problem with this one. Actually see what happened. You had white, so you had a line there. That brush did actually go empty. Even though this one's still full, that one burnt away. It actually went down to the wire or the pin. So that's why they actually pulled this one out. So this was worn away. Why was it worn away? See the spring? nice and tight. This one, no spring left in it at all. That's where the heat went. This side got hot, thing overheated, heated up this here leaf spring, loses its spring, and it doesn't put as much pressure on the brush. So this brush, when running, probably had a teeny tiny gap between it and the armature because there wasn't enough pressure put down. That caused a lot of arcing, a lot of sparking. That sparking erodes the brush extremely fast. So that's why this one's fine and this one's gone. So hopefully it didn't damage the armature with all that heat. If it didn't, we'll just get away with putting on a set of brushes. These Hikoki grinders are fairly cheap to buy. It's not really worth putting a lot of money into them. It's particular models anyway. So this is the G23 ST. This is their later version one. It's about 1,800 watt motor or something. 2,000 watt. Then you get the G23 S2, be a heavier one, and then you get an S3 as well, which will be the proper heavy duty machine. This is just a bog standard one. Probably about 130, 140 euro for that machine. So it's just not worth putting an awful lot of money into it. Wouldn't be worth a new armature anyway. That's the parts we need. Number 59 brushes and a new brush holder. Can't actually buy the springs separately on this model. You have to buy the actual brush holder as well, but even still, it's not expensive. That's another thing I need actually. I need another door for the other side. Luckily enough, plenty of these things scrapped off. Plenty of second-hand parts on them. Second-hand door will do fine on this. Now, the question is, what run? She runs, motor's good. There's a bearing gone up on here. Sure, we've come this far, may as well go a bit further. Yeah, that bearing's gone on the head. This one should be okay. I had a feel of it when the armature was out and it seemed alright. Yeah, that one's fine. See if we can press this out here. Replace this bearing. Yeah, it's gone. See if we can press this out on the bearing press. Now, because we're pressing on this shaft here on an aluminium housing, you want plenty of support. Build some big flat washers to spread the weight over the whole housing and press it out on top of that. Now this will be tight. As you can hear, they open with a queer bang. Normally always dead tight. There's a good bit of force to get that pressed out. Just a wee felt boy on the bottom, stop oil leaking out. Keep that in place. Just totally shot that one. She wasn't going to last much longer. 6302. One thing you need to do is put some Loctite onto these two screws. These do tend to back out, so we want to make sure they're as tight as possible and locked into place. Now it's just a matter of pressing it all back in again. You'll want to do this in two parts. Put your bearing onto the shaft first and then press on your gear. So it's not a big old load to press on. Then your gear. As you can hear, she's a tight fit. That's her. Simple as that. Don't forget your C-clip. Not that it's needed, but just in case. Now, could clean out this grease, but it actually just looks bad. It's not completely solidified. That will move around once it starts to heat up, just to help it. Sometimes put a bit of lighter grease in as well. That'll mix with other stuff, make it a little less viscous. Plus, I don't want to be spending too much on this because they don't want to spend an awful lot of money on it. That should be her. Now, she should sound an awful lot better. That's the job. One Hikoki G23 ST 9-inch angle grinder up and running again. You can actually pick them up for about €100, anywhere between 100 to 120. They're not expensive to buy, which makes fixing them a little risky. So even just this repair, set of brushes, brush holder, bearing and a door, well not the door actually, that's second hand, and a little bit of labour, that actually costs about €48 to fix this thing, compared to about €100 to buy it again. So you're very quickly at the halfway mark for fixing these things. Just watch them if you are doing them. They're that cheap to buy, sometimes they're not worth fixing at all. Just to give you a heads up, if you are fixing them for a living, don't spend too much money on them. So last up now out of this pile is a Bosch drill. This is the GBH 2-stroke 26F. This is working. Losing oil from gearbox. Right. Same crowd doing very heavy work. It's actually a 2022 machine. They're using this as a wee chasing hammer. And it's getting used and abused for hours. What can we do here? So we actually get this change lever off first, put it to drill mode, get a long pokey thing, push that red tab all the way in and keep turning. Then it just pops off. So as you can see, the grease well used. You can see this grease is going to be burnt. See, this will be just like the other Hikoki one. I can still smell the grease from that on here. When this grease burns up, it generally stinks. Take this brush ring out, put it all the way over to one side, pull out your switch, put your brush ring, selector ring into the midway position, and then just give it a wee wiggle, a jiggle and a pull. And it pulls straight out. I suppose I have to take this apart anyway because it has an oil leak, so I'm going to have to clean this out. Still got good enough compression, but we'll change that O-ring as well. Yeah, it's pretty well burnt up. So we will just change this grease. Right. Holding the armature on, there's a steel plate, 2 screws. Just locate the slots on your fan. You can take the screws out. Them bearings are actually gone. So replace them. There's no actual oil seal on this thing, you see. So the problem is, same as the last one, when she gets too hot, when you're running this for hours on end, all this heats up. This whole gearbox section will get hot. Makes the grease inside hot, so it becomes less viscous, becomes more runny. That runny hot grease eventually starts to weep out through here because there's no actual seal on this. There's just an O-ring on here and then the oil seal on the bearing, but it starts to weep out through and slowly drops, gathers. So that's where that grease comes from, but as you can see it only does it and she's done a fair bit of work. So I'll get this all pulled apart, get it cleaned, re-greased and put back together. Take this sleeve off so we can take the tool holder out. It's just held in by a C-clip. And they do like to go flying, so get ready to catch it. There's another one down in here. Find out which. We pull out. Now, less grease tends to come out through the tool holder, but it still can. The tool holder is okay. There's an oil seal up inside of here as well. But again, once this is running very hard, but a grease can come out. If you find your SDS roll actually leaking grease like this, you're using it way too much and way too hard. You're using something, I guess, so much that it gets this warm, starts leaking the grease. You need two machines. You need one for when you're running, run it till it starts to get hot, put it down, pick up the other machine, start using that for an hour or two. Whenever that gets hot, this one will be cold, you can start using this one again. Same for hammers. If you're in wall chasing, if you're going through a lot of hammers, buy two and rotate them round. They last twice as long. Get it cleaned up, all clean surfaces, no old grease left. I'm going to put on a different type of grease, might help this a bit better. That's where the bulk of the grease is going to be. A lot of black tar out with that. What you want to do is really clean the fan. Try to get in there and get every single fan blade cleaned. So what's actually happening, the main reason why people leave these on when they're leaking grease, is because the grease gets on the motor and the fan, gets us wet, and the dust and debris starts sticking to it. So then whenever you're running this machine and it's up close to your face, all that bits of grit is breaking off the fan again, with lumps of grease coming flying out through the vents and hitting boys in the face or on the eyes. That's when they start to notice there's a problem. So if they're sending in for grease, you want to clean this out just to make sure the actual bit they're noticing the most isn't going to start doing it again the second they switch it on. So sometimes that fan can hold quite a bit of gunk that you really need to get off. Just replace the two of them. Leave it right. That's about a 607. Yep. That is where the grease is going to be getting through. So she's a 609. 609 actually, as you can see. The amount of play in that. So that seal is now loose. The grease and oil is actually getting through the seal, through the bearing, and out the other side. So change that. Get these two pressed on now, and the bearing press. That's her. Both bearings pressed on and ready to go. We'll just change this O-ring as well, just in case. You never want to put these on dry, so a wee touch of grease on them. That on there. You can refit your armature. Put some grease in there to begin with. And line up the steel plate with these two holes. Press it on. That's that. Only other thing I want to change on this is just this O-ring, just to ensure it's getting good compression. Probably not necessary, it's just better to do it when you have the thing out. Grease in this thing, I'm using the wrong stuff. I'm using this 001 grease, which is like a thick gear grease. It's great for getting seals and everything tightened up for initial startup. Actual grease then you're meant to use is 015 grease. This here Bosch grease. It is a lot lighter. Less viscous, so as you can imagine that becomes a lot more runny at higher temperatures compared to this one. So because the company is using this and we already know we're overworking it, I'm going to use the heavier stuff instead. It should help keep this heavy stuff in better compared to the lighter stuff, but there is a trade-off. This will be harder on the motor. So I'll run this myself for about 5 minutes or so, gently, to get this here worked around the machine. So it will be a wee bit tougher on the motor getting this here up and running. But hopefully in the long run it'll be harder for this grease to leak back out again. Plus the new bearing with a better seal on it, it should last a good bit longer. Should stay inside the machine anyway. This wee lever then just sits up there. That's all it needs to do. Just make sure there's grease up here for running on the needle bearing inside the housing. Now make sure there's everything, a good coating of grease. Back here doesn't matter so much, it's not happening back this side, it's just all up here. That grease will eventually work its way through everything anyway. sure your name badge is on there as well, just for helping identify the thing in future. Now you can also pump some grease onto this through this change lever hole if you wanted to. You can just squirt it on directly from there. I think there's enough on this one for now. I'm going to put this change lever on. You can see the markings. These are for the different modes. This one slides all the way to the bottom. And your pin is sitting on this one cross section. So there's a wide one. These are 3 narrow ones and one wide one. So this pin is going to this top one. So to get it on, make sure the pin goes in to the selector spring. See this one here? So that's the actual selector for the modes. Make sure the hole for the spring in the middle is sitting up here. So whenever you drop this on, this pin goes onto the selector. As you're putting it on, push the red button all the way on. That's it. That's one of the reasons I started doing these videos. Things like that there, if you work on these machines, unless you've worked on it before or know somebody or somebody there to ask, the only way to get that off if you don't know is by luck, or to break it off and figure out then how it goes back together and replace the part. 3 things like that there. If it's not available to know, there's no way of knowing unless there's somebody online to show you. Very simple when you know how. If you don't know how, that's where the problems start. So that leads on there. As well, I pull these off to take the field out. So these have to go back in. You just press under the spades. There's 2 heat notches as well. Pins for them to go under the body. These can wear out sometimes, but not very often. Not a 2022 machine anyway. Now to put the brush spring back on. So we're putting it on then. These 2 springs have to be sitting in the center and push it directly down all the way to the bottom, and you can slide around again and just push that wee tab out again, and that will release the brushes. That's it. And to install your switch, this has to be over to one side. So you can get your switch in, and this one on second. Now this is probably the most tricky, most irritating anyway. Sleeve on. So I can do this in a way that you can see. The steel ring goes in. Make sure that's all the way down. You need to install this C-clip. Get that on. That holds that ring in, which holds your sleeve on. You put your spring in. Big steel washer. Then you have to hold all this on whilst then putting on this big C-clip. To make it a wee bit easier, get a deep socket, push in the steel ring with the socket. And then you can try and get your C-clip into place. That's it. And you can simply stick your chuck back on. That's her. Hear the tone change of that motor as she's getting up to speed. That's the actual heavier grease working its way around inside. That's her. One Bosch GBH 2-stroke 26F. Cleaned out, washed out, all the old grease removed and cleaned out. 2 new bearings which were leaking, were letting grease through, replaced. New piston O-ring. A new motor housing O-ring replaced. Hopefully with that heavier Bosch grease in it now, it'll be harder for this thing to actually leak any grease out. For now, she's running perfect. I'll keep these boys running for a bit longer. It is getting a fair bit of hard use, so that heavier Bosch grease should be a better job for it. That's her. This is a wee quick one for you, well, more of a tip than a repair. Concrete nailers, steel concrete nailers. Okay, there's a wee cheaper brand, S&K. This is actually quite an old nailer. Not even sure if you get parts for this particular one anymore. These shoot under 10 bar pressure into concrete. They fire a solid steel nail, a 15 gauge steel nail, or you can use them as for a 16 gauge nail, normal brad nail. So use a standard nail or a steel nail. Obviously if you're firing into concrete, you're going to need a bigger compressor, a 10 bar compressor instead of an 8. This boy's having trouble with these 16 brad nails, so keeps jamming the pin and keeps damaging the nails up here, keeps bending them at the end, not driving them. Different problems, but it's only the 16 gauge. Problem is the pin. So, pin's not actually broken, works fine on the 15 gauge steel nails. It's only on the lighter nails that you're given trouble. Generally, because she's firing steel nails, hardened steel nails into concrete, it's fairly hard on the pin. So generally what happens, she starts to round over. See just there? So that pin is meant to be square. It's just now mushroomed a little bit. So you can either replace this at what, 40 or 50 quid, if you can still get it, or if you want to do a quick fix on it, get a file, clamp this in a vise, nice and square, and run a flat file across here, and just file off tiniest little bit to get a good square flat edge again. I'm not going to film the filing because it makes a horrible sound. It's a hardened steel pin, so it's not the easiest thing to file down. That will keep you firing for a little bit longer. Gives you a nice flat square edge for this to actually pick up the 16 gauge brads now. So you're not taking enough of it to make a difference to the depth. So adjust your depth a little bit to fire it deeper. You only get away with doing this a few times before it becomes too short and starts leaving the nails proud. But that'll run your 16 gauge no problem now. And it'll take a good long time of firing the steel nails before this will wear down again. Just a quick wee fix to get it firing again. It's not a proper repair. When the man needs it now and I don't have a pin, it's the only option available. That's it, just a wee quick tip. That'll keep your man running for a bit longer, till I start using concrete nails again. Now, next up we have an oddball. This odd looking thing is called a burnisher. Doesn't sound good anyway. So it's for working and finishing metal. So you put a round disc onto this here, either a sanding disc or Scotch-Brite or something, or even polishing. Variable speed, so this is for finishing welds or plate steel or something, giving it a better surface finish. This particular one, don't know what it is. No labels left, can't see a model, nothing, not even a manufacturer stamp. It's identical to the Walter Linemate. I think it's a Walter Linemate 3, I think you get them in the States, but that's a yellow machine. Exact same machine, same head, same handle, exact same profile. Identical machine, just the wrong colour. This one's purple for some reason. So I don't think it's a Walter Linemate. Maybe it's a Sparky. I don't know. It's the right colour for a Sparky anyway. Probably they're just buying it from a manufacturer. They just change the colour for different brands. This one, customer says it sounds rough and it's smoking. That doesn't sound good anyway. This may simply be a lost cause. One thing fixing a machine, but it's a different thing trying to fix a machine when you don't even know what brand or model the machine is. If you don't even know the brand of it, you're not going to get spare parts for it. There's no point in switching this on with it sounding like that, but the brushes look okay. Actually not looking bad, but that's a problem. So it's a bearing. It's actually a nice tidy machine. That's a well-made armature there, good and tight and compact. The armature itself doesn't look damaged. That bearing obviously is. This is the main problem. That is the tacho for running the speed control. So without that, you've no variable speed. You'll notice they go, because when you switch them on, they'll go full speed and then they'll die down and stop. That means the speed control is not getting the feedback from this to know how fast the rotor's going. If it doesn't get the feedback, it normally just shuts down. This might be able to be saved, but with a little bit of bodging. A chance changing this bearing, and then put a bit of glue onto this and set that back on again. This doesn't have to be centered on too much, it's just for a bit of feedback. As long as it's there, it should work, as long as the actual magnet inside hasn't cracked and given you two different poles. First, we'll get this off. So that's a 627 bearing. Imagine the heat that one generated. That is all kinds of gone. Bone dry. That's pressed on now. Should be ready to go. Trying to work quick here because it's lunchtime. I want to get this done before I leave, so it can be set. So it can set whenever I'm away. Gorilla glue. That's just a 2-pack epoxy glue. Very good for this sort of stuff. Get a bit of that out there. Don't need too much. Put the cap back on. There's two types. One's a glue, one's a hardener. Very good for keeping, for longevity. This won't go off unless they're mixed. This stuff stinks. Give it a really good mix together to activate it. Whenever this goes off, it will go off good and hard. It'll hold to just about anything. Try again. Yeah, that'll do. You don't want to spill it out everywhere. Let that sit now over lunchtime. Hopefully it'll be alright by the time I come back. Okay, I'm fed and I'm watered. And this should hopefully be set. That's set enough anyway. So that should be set. Right. We touch of grease on just to help this slide on. She's not smooth, but she's not bad. Now, hopefully she runs. Not a cheap machine to buy, these Burnishers. So we can get an easy fix like that there, just for a couple of bearings. Why not? Sure, if you can get that running for a few bearings, why not? So for one bearing, we test the glue and about a time gets that up and running again. Whatever brand it is, imagine it's a Sparky or something. €28 gets it running again. Not too bad for what, €200 machine. Keep running for a while longer till she totally packs on. And the last tool today, be a wee quickie. One wee quick fix Milwaukee, hopefully. Not a good sound anyway. Not a good start when she's that stiff. First thing, does she work? Yep. She's trying to run, that's the main thing. Get that off. Get that off. Now, I think we already know what this one is. This is as common as the Makita one with burnt brushes, Milwaukee, with a bad bearing. Yep, there we go. Bearing's gone. And the motor still works, so this will be worth fixing. There's the bearing. 1605 failed bearing. That's what you need to be careful of. Make sure you get all these steel balls out. They can get in everywhere. Feel seems alright. Piece there, look. Doesn't seem to have torn up anything else. Right, I think that's it. Can't see anything else. Chance that. First thing, get this old bearing off. As you can see, this one's actually been done before. So this will be the second bearing it's got. Now, you have probably seen this particular repair on the Milwaukees quite a few times now on my channel, between videos and shorts. But here it is again one more time. Now, nothing graceful about this. Get this old bearing off. Get yourself a grinder to fix your grinder. Just cut a track down one side just to free up the spindle. And you should be able to just pull that off. Simple as that. She's been cut twice before. One I just did. Potentially me as well. But still plenty of meat to put the new bearing onto. And it's just a 605 bearing to go on. You can use a rubber shield or a metal. Metal's going to run faster. Rubber's going to give better protection against dust. The body, I don't think it's melted, but it could have. You can see that bearing only actually comes to there. So that's the only bit the bearing's sitting on. It doesn't sit back here at all. If this totally melts, you can just leave the bearing on halfway and it'll actually grab this part down here just to help support it more. Or if you can get your hands on a thicker bearing, do an even better job. But what I do, if I do suspect this melted at all, is just put a couple of wee dents in it. Get a blowtorch and a point. And just put a few dents in the plastic. That'll squeeze it up enough to grip that bearing again. So it'll be a good tight fit. There's only a couple of wee dents, you're not melting through. just enough to help resist that bearing if that's at all worn. In any sort of way suspect the bearing on one of your Milwaukees is bad, get them changed, because they do go quick. So if they're starting to sound rough, change them before they go bad completely. Make sure there's nothing stuck to the rotor, because that's one big magnet. So that's actually 4 neodymium magnets inside. Any metal, dust, shavings, ball bearings will stick to that fairly quick. So just make sure she's clear before reinstalling it. Make sure she's free. Look at that. One Milwaukee M18 CAG 115XPDB up and running again with a new 605 bearing. I said it before, these would actually be one of the top grinders available if it wasn't for them bad bearings. Milwaukee would just put on a bigger bearing and a better quality bearing, even just a better quality bearing, these would actually be a top class machine. But them bearings every time let these things down. If you hear them going bad, lads, if it starts to sound rough, get them changed quick. But for €25, it's not an expensive repair anyway. That's her. That's enough for the day. That's everything done. As much as I can do today anyway. Hope you're enjoying the videos, lads. Hope you're enjoying these longer format ones. I know everybody is actually asking for the longer ones, so that's what I'm trying to do. Just trying to do a day-to-day sort of repair schedule, what's happening in the workshop, stuff coming on, sort of see the regular failures, the regular machines that are coming on a day-to-day basis. Sometimes you might see me putting up a long video like this, and then you might see another video later of one of the machines on its own, a longer version of that. I do actually have done, and I will be posting repeat videos on certain machines. So the likes of these longer videos now, if I hadn't actually had a longer Milwaukee video up about this bearing, I would stick up a dedicated video on that. So if a machine comes on that I don't have a video on, there is a common failure on, or a common machine you would be getting and seeing quite often, I will put a dedicated video just on that there up. So if anybody's searching for it on Google, they will find it easier than just finding these here long format videos. People might not want to look through a whole hour long video just to see the repair they want. So if you see me posting a repeat video of a machine that was in a longer format video, it's simply there for people to find on Google if they want to fix a machine themselves. Because basically that's why I started doing these videos. Some machines, if you haven't worked at them before, it'd be very helpful if you could find a video online showing you how to dismantle it and put it back together. I know for me, they were never available whenever I started doing this stuff, and a lot of the time it would have been very helpful. So that's why I started putting these up. So if you see a repeat video, don't worry about it, lads. It's only to help people further down the line in the future. Anyway, thanks for watching. Hope you are enjoying all the videos, lads. If there's any other suggestions or stuff you would like to see, don't be afraid to ask there in the comment section. And as always lads, give us a like and a follow and hit subscribe there if you're enjoying the videos. Plenty more tool videos and repair videos will be posted regularly. So hit follow if you want to see plenty more. Cheers for watching.